Hi, I'm Jonah Comstock, Editor-in-Chief at Pharma Forum. I'm here at the Informa Biotech Showcase in San Francisco for JP Morgan Week, and I'm joined by Tim Liu, the CEO of Senti Bio.
Yeah, thanks a lot for having me.
We were just on a panel together about advances in cell and gene therapy, and
Yeah.
you're doing something really interesting and unique at Senti with these logic-gated cells. Tell the folks a little bit about how that works.
In a nutshell, we're essentially trying to put AI into living cells. So we're trying to program cell therapies that can go in the body, hunt down cancer cells and kill them, but at the same time, recognize healthy cells and protect them. And we do that through that technology we call logic gates. We think this is potential to solve one of those central challenges in cancer that we've had for over 20, 30 years, which is how do you distinguish cancer cells from healthy cells specifically? And we can now program cell therapies that can do that sort of thing.
So traditional cell therapies are hitting a lot of cells that they aren't cancer cells.
Traditional cell therapies and traditional biologics, ADCs, what they're trying to do is they have to find one clean target that's on the cancer cell and not on the healthy cells in order to only kill the cancer cells. If you can't find such a clean target, the problem is these therapies will go in the body and kill off a lot of different cells. Some of them are the cancer cells, but some of them are the healthy ones. And that might work, be okay for certain diseases. You can find clean targets, HER2 for breast cancer as an example. But for a lot of cancer indications like AML, acute myeloid leukemia, you can't find that clean single target. And so as a result, you can't have these, current drugs solve that sort of problem where using our logic gate approaches, we can come in and basically tackle that problem head on.
So this technology kind of opens the door for a lot more use cases, just in cancer or even beyond cancer.
Yeah, I think in cancer, there's already a plethora of indications we want to go after. Certainly beyond that, we've thought about opportunities in autoimmune disease examples where, again, specificity against certain targets is really important. But right now, we have our hands full already with cancer, just given the number of opportunities that are really unaddressed right now with current modalities. Yeah.
How does it work? I mean,
Yeah.
and how is it that nobody's kind of tumbled to this before?
Well, like this concept's been in the ether for the last 20 years. Before starting Senti, I was actually a professor at MIT for about 12 years, and we spent a long time trying to build this core technology of logic gates and getting it to work for humans. So it's a really technically challenging thing to do, to try to engineer a therapeutic that can recognize and respond to multiple things inside of the body. So what we had to do was engineer a cell that contains two different receptors. One of the receptors recognizes one or more cancer targets and kills those targets, and a second receptor that recognizes the healthy cells and does not kill. And so it's like this accelerator on one hand and a brake on the other that you have to design and balance with respect to each other. There's a lot of complex engineering, but we managed to, over the last 10 years or so, from the basic bench to get this into humans, and now we showed clinical data in patients. So we're really excited about that journey.
It's like an if and only if operator.
Exactly. Yeah, exactly.
Back to my philosophy, logic.
That's right. Yeah, you can basically make Boolean logic in living cells now.
So we're on to Tuesday, day 2 of the conference. Plus, there was whatever over the weekend.
Yeah.
Anything interesting you're seeing or hearing about what to expect next year in biotech?
I think for cell therapy, it's a time where the field has certainly been through transition. We had a first wave of cell therapies really exciting that have now come to the forefront and are now commercial products. And then there was I think a period of time over the last few years where people were trying to figure out what's next for cell therapy, right? And now we're seeing the emergence of sort of the next generation. People are starting to apply cell therapy, whether it's ex vivo or in vivo, to autoimmune disease. That's certainly one exciting expansion place. And then for us, it's really about expanding the indications for cell therapy beyond the traditional ones that are out there. So we had put out data at ASH just about a month ago showing best-in-class efficacy in about 20 patients using our logic-gated approach. And I think that is continuing to generate excitement in the community, both clinical and in the investor and the BD side of things. We're looking for that to continue.
Yeah, we talked a little bit on the panel about how innovation in cell therapy is sort of growing in 2 directions, right? Where the science is pushing the envelope of what it can do, but then also the infrastructure is getting built out around making sure that once you do that, you're able to scale and you're able to deploy it, you're able to pay for it, all that stuff.
Yeah.
I mean, how do you think that those 2 dimensions are evolving at this moment?
Yeah, the interesting thing about, I think I mentioned on the panel as well, is that unlike biologics therapy that were all manufactured on the same common CHO cell platform, where like an improvement on a CHO cell can impact many products at the same time. One of the challenges in the cell therapy side is many of us are working on slightly different processes, slightly different cell types, et cetera. So that perhaps in the past has made it just more difficult for everyone to centralize all their efforts together. I do think now that we're seeing, multiple cell and gene therapy products starting to make, real impacts in patients, that there's the impetus to have people invest in building that infrastructure up. So there's been a lot of, I think, improvements over the last several years in introducing automation, introducing scale. Like, our product is an allogeneic off-the-shelf product. So introducing scale can significantly improve cost as well as turnaround time to get these sort of products to patients. Yeah.
Awesome. Well, thanks so much for chatting with me, Tim. I
Yeah.
really enjoyed the panel and really enjoyed this conversation.
Thanks a lot. Appreciate it.